Imagine, if you will, ancient India, a land of vibrant colors, bustling cities, and profound mysteries. Within the sacred texts, the Vedas' whispers of magnificent flying machines echo through the ages. These were not mere chariots, but entire palaces, adorned with intricate decorations capable of soaring into the heavens. These palaces were known as Vimanas. Could these Vimanas be more than just mythological fantasies? Some believe they were based on a real advanced technology, a lost art from a forgotten era. The ancient texts describe various types of Vimanas, each uniquely designed and named after the creatures of the earth and sky. There was the elephant Vimana, powered by multiple engines, and others named after birds and animals, each possessing unique capabilities. Imagine a Vimana for local travel, another for journeys to distant lands, and yet another capable of traversing the vast expanse to the moon and other planets. These machines were said to achieve incredible speeds, blurring the line between reality and dream. One Vimana possessed the power of invisibility, cloaking itself from the eyes of the world. Another, shaped like a sphere, harnessed the winds of Mercury, generating a solar-like ray and a thunderous roar. All Vimanas were designed to be virtually indestructible, formidable weapons against any foe, but operating a Vimana was no simple task. It required a deep understanding of complex principles, much like piloting a modern aircraft. 32 secret techniques were essential, encompassing the aircraft's structure, takeoff procedures, and maneuvering skills, all to prevent a catastrophic crash. A pilot was expected to master the art of invisibility, concealment, rapid movement, and even manipulating the size of the craft. To shield the Vimana from enemies, pilots were instructed to ascend to the 8th atmospheric layer and harness the power of dark solar rays. While some instructions seem enigmatic, others resonate with modern aeronautical principles. Ancient texts delve into intricate details such as flight paths, pilot training, navigation techniques, appropriate attire for pilots, and even recommended meals for long flights. These texts also detail the use of heat-absorbing metals, their composition, and melting points, suggesting a sophisticated understanding of materials science. Proponents of the theory that Vimanas were more than mere myths argue that such detailed descriptions would be unlikely for a simple fictional tale. Perhaps these flying palaces were real, technological marvels far ahead of their time, mirroring other remarkable Indian inventions. Let's journey back further to the 6th century BCE, where an Indian physician named Shasharuda penned what is essentially the original guide to medicine and surgery. Revered as the father of surgery, Shasharuda meticulously documented hundreds of medicinal plants and detailed complex surgical procedures. He provided instructions for intricate nose reconstructions and skin transplants, transferring skin from one part of the body to another. The original method of rhinoplasty, utilizing skin from the forehead to rebuild the nose, remains in use today. Back then, these procedures were not about likes on social media, but about restoring dignity to those who had lost their noses as punishment or in battle. Now, consider the profound impact of the ancient Indian mathematical genius who gifted the world with the concept of zero. It may seem trivial, but without zero, our binary system and computers would not exist. Before the 5th century CE, people only used a sign to indicate nothing. The invention of zero revolutionized mathematics, simplifying addition, subtraction, and other fundamental operations. The oldest known zero is etched into the walls of a temple in Gwalior, India, a testament to this monumental achievement. Even earlier, around 1500 BCE, the Indus Valley civilization employed rulers with remarkable precision. Discovered during excavations in present-day Pakistan and northwestern India, these ivory rulers were crucial in architecture. Their units corresponded to slightly over an inch, marked with precise subdivisions within 5,000th of an inch. Consider standardization, a concept rather than a physical object. It's about establishing rules based on a group of people, things, or interests. Standard weights are a prime example. Whether pounds or kilograms, universal measurements are essential. For this, we must acknowledge the merchants of the Indus Valley civilization, who, around 4,000 years ago, used standardized weights to measure everything from food grains to luxury goods. Their weights incorporated decimal and binary mathematical systems. Without high-tech equipment, they achieved remarkable precision, using complex calculations and even sand for construction. Their standardization practices spread to Persia and Central Asia, ultimately shaping the global standard for weight measurement. Imagine, not so long ago, the idea of carrying the power of a computer in your pocket seemed like pure science fiction. Yet, here we are, decades later, living in that very reality. We take it for granted now, but let's rewind to 2002. Companies like HTC and Xenarc Technologies were just beginning to experiment with touchscreens, laying the foundation for the ubiquitous devices we clutch in our hands today. These seemingly simple screens have revolutionized countless industries, reshaping how we interact with the digital world. While the late Steve Jobs might not have single-handedly invented the touchscreen, his role in popularizing them, in making them accessible and desirable to the masses, is undeniable. He transformed a niche technology into a cultural phenomenon. Now, picture this: strapping a personal jet engine to your back and soaring through the sky. For years, the jetpack has been a symbol of futuristic freedom, but the reality, as is often the case, has lagged far behind the dream. Despite countless promises of a practical jetpack hitting the market any day now, the technology remains stubbornly out of reach for most of us. Why? Several formidable obstacles stand in the way. First and foremost, the human body simply isn't designed for flight. We lack the inherent lift mechanisms of birds. We can't just flap our arms and take off. That means all the necessary lift has to come from the sheer force of the jetpack's thrust. And thrust, as you might imagine, requires a lot of fuel, which translates to significant expense. And here's the kicker: the more fuel you carry for longer flights, the more weight you add, which demands even more thrust to stay airborne, resulting in a vicious cycle of fuel consumption. Most jetpacks rely on rocket propulsion, which necessitates carrying both fuel and an oxidizer. Furthermore, controlling these contraptions is notoriously difficult. They can be dangerously unstable in flight. The limited flight time restricts the pilot's ability to reach a safe altitude, making emergency situations like engine failure potentially catastrophic. And, let's face it, the sheer inefficiency of propelling a single person through the air with a jetpack makes it impractical for most applications. So, while they might look undeniably cool in movies, the practicality and cost-effectiveness of jetpacks remain elusive. Then, there's the laser. The idea of harnessing light itself, focusing it into a precise and powerful beam, sounded like something ripped from the pages of a science fiction novel. That is, until lasers were actually invented in the 1960s. Since then, these remarkable devices have completely transformed industries. Medicine, fiber optics for communication, and manufacturing have all been revolutionized. Lasers are used with astonishing precision for cutting, welding, and countless other applications. While lasers now come in a rainbow of colors, creating a true white laser presented a unique challenge. White light, unlike the single wavelength of a typical laser, is composed of a spectrum of different wavelengths. But instead of viewing this as an insurmountable obstacle, many scientists saw it as an irresistible puzzle. One approach involves combining multiple lasers to create a beam that appears white to the human eye. However, achieving this without sacrificing coherence, maintaining the beam's focus and intensity, is a formidable task. Yet, some researchers have already succeeded in creating a white laser using a single crystal, demonstrating the boundless potential for innovation in the field of optics. Let's step back in time to 1903. Henry Ford, a man with a vision, was forging ahead with his fledgling automobile company. Yet, even his own lawyer was advised against investing in Ford's venture. A mysterious, unnamed individual confidently declared that the horse would always be king and that cars were merely a fleeting fad. Fast forward to 2021, and there were nearly 300 million registered vehicles in the United States alone. Take that, Mr. Anonymous Advisor. But, jokes aside, at the dawn of the 20th century, the concept of cars was far from universally embraced. Many Americans simply weren't sold on the idea of automobiles clogging up their cities. However, as highways proliferated, suburbs expanded, and even anti-walking laws began to emerge, society gradually shifted towards a car-centric lifestyle. This transition came at a cost, reducing the emphasis on walkable communities, which in turn diminished our ability to simply stroll through our neighborhoods to connect with our surroundings on a human scale. Now, let's address a common misconception: that the price of lab-grown diamonds will plummet dramatically in the future. This notion is often promoted by the mined diamond industry, which claims that lab-grown diamond prices will eventually sink to the level of inexpensive diamond simulants like cubic zirconia. The truth is that high-quality lab-grown diamonds are surprisingly rare and challenging to produce. Growing brown or industrial-grade lab diamonds is relatively straightforward and cost-effective. However, cultivating colorless, high-quality lab diamonds is a complex and expensive process, mirroring the challenges of mining natural diamonds. Therefore, it's essential to recognize that there are two distinct categories of lab-grown diamonds: high quality and low quality. The vast majority of lab-grown diamonds on the market fall into the low-quality category, while high-end retailers typically offer access to superior quality lab-grown diamonds, which are significantly more difficult to cultivate. The process of growing high-quality lab-grown diamonds is inherently challenging due to the fundamental speed limit on how rapidly a diamond crystal can be grown. Attempting to accelerate the growth process can result in diamonds with fractures, low clarity, and undesirable undertones. Taking shortcuts, such as adding boron during growth, can lead to low-quality lab-grown diamonds with a blue tinge or a brown color that requires irradiation to remove. Cutting and polishing. Polishing laboratory-grown diamonds is no walk in the park. It's a costly and painstaking process, demanding the use of laser tools that can cost millions and the expertise of highly skilled technicians. Similarly, blasting off into space currently costs a king's ransom. But what if there was a more affordable way? Imagine stepping into an elevator, pressing a button, and in moments, you're soaring among the stars. This might become reality thanks to nanotubes. But imagine something goes wrong. Disaster strikes. Something collides with the elevator mid-journey. You're trapped, stranded, and doomed to drift in the cold void of space forever. Today, if you want to experience space travel, prepare to spend upwards of $55 million. However, the not-so-distant future might offer a far more accessible option: space elevators. The idea of galactic lifts might sound like something ripped from the pages of science fiction, but it's a very real possibility poised to revolutionize how we access space. With an estimated price tag of $8 billion, space elevators could represent a one-time investment that pays dividends indefinitely. Consider this. NASA alone burns through approximately $2.7 million worth of rocket fuel per minute. A single rocket launch can cost a staggering $178 million. Elevators could drastically cut these expenses. Think about the super tall buildings we see on Earth. They all rely on massive foundations to provide balance and support their immense weight. As your eyes travel upwards, the structure becomes progressively thinner. Even the Burj Khalifa, the world's tallest building, is broad at its base and tapers to a point. If we were to build something like a gigantic lift using conventional construction methods, we'd need a truly colossal concrete foundation, which defeats the purpose of saving money. Now, picture this. Take a piece of string, tie a ball to one end, and start twirling it around. The string you're holding remains fixed, while the ball orbits your hand. This illustrates the concept of centrifugal force, and that's how our space elevator would function. The ball, in this case, would be a base station positioned far out in space, with the rope extending down towards Earth. The station where we board the elevator would be located in the middle of the Atlantic Ocean, with the tether stretching upwards from there. For this to work, the cable must be perfectly synchronized with Earth's rotation. Otherwise, it would snap or wrap around the planet like a misplaced scarf. Furthermore, the orbit of the cable has to be a perfect circle, as it wouldn't be able to shorten or lengthen. Scientists have been hard at work, wielding the power of algebra to find the optimal solution. Don't worry, we won't get bogged down in complex equations. Let's cut to the chase. The precise distance from the Atlantic Station to the space station must be 36 miles above the Earth, the point where geostationary orbit begins. At this altitude, the outward forces are significantly stronger than the downward pull of gravity. This is what keeps the space station in a fixed position. When constructing a house or a building, the process typically begins at ground level, working upwards. But building this engineering marvel requires a reverse approach, starting from the top and working down. The primary challenge lies in the immense weight. If the cable is too heavy, it would disrupt the orbit, and the entire system would fail. Therefore, balancing the station in space is crucial for flawless operation. Steel is renowned as one of the strongest materials on Earth. The cables in everyday elevators are made of steel. However, when you need a cable that stretches 22,036 miles, things become complicated. While steel is incredibly resistant to breaking, it's also extremely heavy. And when you're dealing with that much material, problems inevitably arise. We rely on heavy steel in construction all the time, but lighter materials could potentially reduce the stress on the station and eliminate this hurdle. Additionally, the cable would need to be tapered, becoming thinner towards the end point where stress is minimal. However, even at its thinnest point, the cable would still need to exceed the calculated minimum thickness due to safety considerations. At the starting point, the cable might be around 0.5 inches thick. After some rather complex mathematical calculations, we could determine the required thickness at the end, a number so large it's practically unpronounceable. But trust me, it's substantial. So, steel is out. Another contender is Kevlar, a material 5 times stronger than steel. Furthermore, by incorporating materials like carbon and titanium, the strength could potentially increase tenfold. This composite cable could have a diameter ranging from 262 to 557 feet. This is significantly smaller than the diameter required for a steel cable. The downside? It's incredibly expensive. Ultimately, if we can't find the ideal material for constructing the cable, the entire space elevator concept will remain a pipe dream, a colossal waste of time and resources. If only we had a magically light material with a strength of 60 gigapascals and a taper ratio of 1.6. But hold on a second. We actually do have such a unique material. Imagine a material of unimaginable strength, something ripped from the pages of science fiction. It exists. It's called a carbon nanotube. Possessing a strength of 130 gigapascals, it far surpasses what's needed for groundbreaking engineering. These nanotubes, crafted from pure carbon, are incredibly small, 100,000 times thinner than a human hair. Yet, this seemingly delicate material is incredibly strong and exhibits impressive conductive properties, a feat made possible by its unique atomic structure. We already see this material in diverse applications, from advanced batteries to cutting-edge optics, but its potential extends far beyond, as it can be modified and adapted for countless other uses. The visionary behind the audacious idea of a space elevator is Bradley Edwards. NASA, in its pursuit of innovation, issued a challenge. Don't do anything too crazy, but start building a space hoist. Edwards, seemingly taking this as an invitation, embarked on the ambitious elevator project. He penned a paper detailing a galactic conveyor, anticipating rigorous scrutiny and the identification of flaws. Surprisingly, his work stood firm, with no critical errors found. Edwards' concept involves securing a carbon nanotube line to a rocket and launching it into the vastness of space. The opposite end of this tether would then descend towards Earth, where specialized robots would ascend the rope, progressively lengthening it. This would pave the way for the construction of an elevator space station. Once established, the elevator could transport a range of cargo, from crucial solar panels to eager tourists. In the not-so-distant future, space tourism might become a reality. Imagine vacations among the stars. But hold on, looking for a pleasant atmosphere for your stellar getaway? Well, you won't find it here in space. Oops. Probably not the best advertising slogan, right? Meanwhile, just a few years ago, we were only capable of creating microscopic carbon nanotubes. However, with continued research and development, these structures have grown significantly. Now they can reach lengths of several inches, projecting forward within 2 decades, they could potentially span miles. Considering that carbon costs around $28 per ounce, Constructing a space elevator would require an investment of approximately 1 billion. While this may seem like a significant sum, it represents a long-term solution for space travel, potentially saving considerable resources in the future. However, despite the promising prospects on paper, NASA has reservations about the project. Currently, over 128 million objects are estimated to be orbiting Earth, posing a potential threat to the elevator's integrity. While the structure could potentially withstand occasional impacts, constant bombardment is not a viable scenario. Nevertheless, Edwards argues that extensive monitoring systems track space debris, enabling the elevator to avoid collisions. Now, what if the unthinkable happens? What if something collides with the elevator or the tether snaps? The consequences, fortunately, wouldn't be catastrophic, assuming there are no passengers on board. In such a scenario, the elevator would simply drift into space, posing no threat to Earth. In Japan, engineers are actively pursuing the construction of a space elevator. This lift could facilitate space mining, potentially offsetting the elevator's construction costs. Asteroids rich in valuable metals could be mined and transported back to Earth. Now, let's shift our focus. Imagine a scenario where humanity faces an apocalyptic event, leading to its complete demise. A black box will be there to tell the story to whoever comes next. Deep in a remote region of western Tasmania lies a 33-foot-long vault designed to document the mistakes that led to humanity's downfall. The creators of Earth's Black Box, a team of artists, architects, and researchers, hope that this art installation, constructed from thick, reinforced steel, will withstand fire, water, and most natural disasters. However, total planetary destruction may be beyond its capabilities. Similar to the black boxes found in airplanes, this time capsule aims to help future civilizations learn from our mistakes and avoid a similar fate. The project is entirely non-commercial and carries a vital message. The box will be filled with storage drives and have constant internet access. Solar panels on the roof will power the system, with batteries providing backup power. When the sun shines, the black box will update itself with new scientific data. A specialized algorithm will filter and store only the information relevant to the project. This includes measurements of land and sea temperatures, ocean acidification, species extinction rates, land use changes, human population data, and energy consumption. The second type of data stored in the box will be newspaper headlines, social media posts, and news reports about key global events, focusing on environmental issues. The creators have decided to encode and store the data in multiple formats, including binary code. Instructions on how to retrieve this knowledge will be etched onto the exterior of the box. Imagine, millions of years from now, some future civilization stumbles upon a time capsule, a black box containing all the data of our world. But even before that distant future, some involved in the current project harbor a fear that curious individuals might attempt to crack open this box prematurely. This solar-powered hard drive is designed with a massive storage capacity, enough to record data for over half a century. Even the most pessimistic scientific projections don't foresee the world's end arriving any sooner. In truth, it might take centuries for the worst to unfold. Let's journey back to the mid-20th century, to the genesis of the idea of a device that would record the events leading up to an accident. This concept took root in aviation. At that time, the world's first jetliner, the de Havilland Comet, suffered 7 crashes in just 2 years, tragically claiming the lives of 110 people. The Australian Department of Civil Aviation sought to uncover the root cause of these disasters. Among the experts involved was Dr. David Warren, a chemist specializing in aviation fuels. He realized a critical gap: the absence of sufficient data to draw meaningful conclusions. There was no record of what transpired in the moments before each crash. Dr. Warren recalled a dictaphone he had encountered at a trade fair, a device capable of recording sound onto steel wire. Inspired, he drafted a memo to his manager, proposing the design of a voice recorder to monitor cockpit activity. This device would also capture flight data and be housed within a crash-proof container. However, in Australia at the time, air travel was not as prevalent, and the manager failed to recognize the potential value of the idea. Undeterred, Dr. Warren began constructing a prototype in his own garage. Later, while in Australia, he presented the finished device to the Secretary of the British Air Registration Board, who immediately grasped its significance. Subsequently, Dr. Warren assembled a team to assist him in developing a pre-production prototype. The proper name for this invention is not black box, but rather flight data recorder. And surprisingly, it's orange, not black. The nickname black box likely arose from the charred appearance of these devices after a crash, or perhaps from the initial practice of painting them black to minimize reflection. It could also stem from the general scientific term for devices with complex internal workings that process data input and output. The flight data recorder consists of two primary components: the data recorder and the cockpit voice recorder. Historically, these were separate units, but now they are commonly integrated into two cylinders. The data recorder meticulously tracks critical flight parameters, including engine exhaust, temperature, fuel flow, aircraft velocity, altitude, and rate of descent. The second component, the cockpit voice recorder, captures audio within the cockpit to facilitate analysis of communications with air traffic control in the event of an accident. This device continuously records data, but only for a period of up to 2 hours, after which it overwrites the oldest sounds. Sometimes, these two parts are combined into a single box-like unit. While the devices record data and voices from the cockpit, their physical location is in the tail section of the aircraft. This placement offers the best protection from impact forces in the event of a crash. The black box is equipped with a locator beacon that activates upon contact with water, emitting a pulse for 30 days. Search teams rely on the recorder's bright orange color as a visual aid. However, locating the box can be a lengthy process, and in some instances, it remains undiscovered. But even long before the invention of the airplane, there existed an original black box of planetary significance, the ancient library of Alexandria. In ancient civilizations such as Egypt, Mesopotamia, and Greece, libraries and archives were not uncommon. However, these early institutions primarily focused on preserving local traditions and heritage. The concept of a universal library emerged with the ambitious vision of the Greeks. They were deeply impressed by the endeavors of their Egyptian neighbors and organized expeditions to acquire knowledge. Alexander the Great, the king of Macedonia, recognizing this thirst for knowledge, tasked his companions, generals, and scholars with providing detailed reports on previously uncharted regions. This initiative yielded a wealth of geographical information and significantly contributed to the establishment of a great library. Much of the information it held was written in Greek. The library housed the books of Aristotle as part of the whole corpus of Greek literature. Some accounts suggest that, in their pursuit of new books, the library's founders would intercept every ship entering the harbor of Alexandria. If books were discovered, they would be taken to the library. If deemed valuable, the library would create a quick copy and return the original to the owner, along with compensation, while retaining the copy. Another tale recounts how Ptolemy III, grandson of the library's founder, offered the rulers of Athens a substantial sum to copy original texts. Imagine a world where the accumulated wisdom of generations was concentrated in a single place. The Library of Alexandria, a beacon of knowledge, housed countless scrolls penned by the greatest thinkers. One can picture the diligent scribes painstakingly copying the works of celebrated poets, only to return inferior duplicates while keeping the priceless originals. Then came the Roman Empire. In a tragic act of short-sightedness, they set fire to this repository of learning, failing to grasp that its preservation might have averted their own decline. In a time before the internet, before printing presses, the library held a vast portion of humanity's collective knowledge. The brilliant minds that gathered at Alexandria did more than simply amass information. They forged connections, seeking to extract the greatest possible value from the data at their disposal. If the Library of Alexandria had survived the flames, we might possess invaluable insights into civilizations that predated our own. Consider the Vikings who settled Greenland centuries ago. Some scientists speculate that access to comprehensive data could have saved them. Perhaps, too, the civilization of Easter Island could have averted disaster by analyzing a volcanic activity, rainfall patterns, and soil conditions. Today, a single person is exposed to more information in a single day than someone in the 15th century would have encountered in their entire life. It's a staggering thought, and the entirety of the Library of Alexandria, every papyrus scroll, could likely be stored on a modern flash drive. We are now awash in data, so much so that it threatens to overwhelm us. We are becoming a global civilization, and the loss of all this knowledge would not simply mean the collapse of an empire, but the potential unraveling of the entire world. Now, picture a lightning strike. A single flash releases around 300 million volts, equivalent to the power of 25 million car batteries. It's a raw, untamed force of nature. Surprisingly, some studies suggest you are statistically more likely to be struck by lightning than to win the lottery. Each year, dozens of people in the US alone become unwilling recipients of this electric jolt from the sky. Our infrastructure, too, is vulnerable. Lightning is drawn to the tallest structures, but under certain conditions, it can strike even an open field. To combat this threat, scientists have devised a laser lightning rod. This innovative device promises to offer greater protection than traditional rods, guarding a wider area with increased flexibility. Traditional lightning rods function like magnets, attracting the electrical charge. These metal spikes, positioned atop buildings, provide a clear path for the lightning to follow, diverting it away from vulnerable areas. The rod is connected to the ground via a conductor, safely channeling the electrical energy into the earth. This redirects the lightning's destructive path, protecting both the structure and its occupants. We owe the invention of these life-saving devices to Benjamin Franklin, some 300 years ago. But these classic rods have their limitations, especially when it comes to safeguarding expansive areas like airports. Their coverage is directly proportional to their height, rendering them inadequate for large-scale protection. Enter the laser lightning rod. When the laser beam strikes the sky, it leaves in its wake a trail of superheated air called plasma. Much like a sculptor carving clay, the laser creates channels in the air, and these channels become the preferred path for the lightning, guiding it harmlessly to the ground. This groundbreaking method underwent testing in the Swiss Alps in 2021, yielding promising results. However, laser lightning rods are not without their drawbacks. They require advance warning and must be activated before a strike occurs. A moment's hesitation can render them useless. Furthermore, the conductivity of the air dissipates rapidly once the laser is deactivated, potentially hindering the rod's ability to safely guide the lightning. One potential solution involves monitoring the electrical field in a given area, predicting where lightning is most likely to strike. Nevertheless, these novel rods require further testing and significant financial investment. In another remarkable application of laser technology, the European Space Agency has explored the possibility of transforming lunar dust into roads. Imagine astronauts driving across the moon, their journeys made easier by laser-constructed pathways. Such a development would revolutionize future lunar exploration missions. This discovery could also address the persistent problem of moon dust clinging to everything. Roads on the moon may seem like a distant dream, particularly since our last visit to our celestial neighbor was in 1972. But when future space explorers return, their ambitions extend far beyond short walks. The ability to traverse the lunar surface by vehicle will be essential for extensive exploration. Imagine a future where humanity has returned to the moon, this time not just for fleeting visits, but to stay. The challenge? Lunar dust. This isn't your ordinary household dust. It's incredibly fine, abrasive, and clings to everything. During the Apollo missions, this lunar nuisance wreaked havoc, clogging equipment, eroding spacesuits, and even causing a lunar rover to overheat. Now, scientists are exploring a high-tech solution: lasers. Picture a powerful 12-kilowatt laser focused on simulated moon dirt, or regolith. The intense energy melts the dust, transforming it into a solid, glassy surface, the perfect foundation for lunar roads. The plan isn't to ship a massive laser to the moon. Instead, the Earth-bound device acts as a stand-in for the sun, mimicking the effects of concentrated lunar sunlight. The idea is to eventually use a large lens to focus sunlight onto the moon's surface. Experiments with varying laser beam sizes have revealed that a wider beam creates a smoother process. Instead of producing tiny molten spheres, a stable layer of molten moon dirt forms, making it easier to manipulate. The result is a glassy, somewhat brittle material capable of withstanding significant downward force. And even if cracks appear, they can be repaired with the laser. The current strategy involves using the laser to create triangle-shaped road segments that interlock like puzzle pieces, forming solid surfaces across the lunar soil. Imagine moon roads constructed from these interlocking triangles. This innovative lunar pavement could also provide a solution for creating stable landing pads. But lasers aren't just for paving the way to our future. They're also unlocking secrets of our past. Consider the dense jungles of Mexico's Yucatan Peninsula, where discovering ancient Maya cities has always been a monumental challenge. For years, experts doubted that any advanced civilization could thrive in such a harsh environment. However, groundbreaking technologies like light detection and ranging, LiDAR, are rewriting history. LiDAR technology provides archaeologists with a powerful tool, especially in areas that are physically inaccessible. Think of it as equipping computers with a pair of eyes. The system works like a flashlight, emitting rapid pulses of laser light. These beams bounce off objects, trees, buildings, the jungle floor itself, and return to the sensor. LiDAR precisely measures the time it takes for the light to return, creating a detailed three-dimensional map of the surroundings. Self-driving cars use similar technology to navigate. By analyzing the returning light beams, the car can see its environment, even in fog or darkness, avoiding obstacles and ensuring a safe journey. Using this technology, a team recently uncovered the massive Maya city of Akumtun. LiDAR allowed researchers to map the jungle floor, revealing hidden structures beneath the dense vegetation. But someone still needed to venture into the jungle and verify the findings on foot. The journey to Akumtun was arduous. The region, far from the nearest airport, remains largely unexplored, accessible only via old hunting and logging trails. The dense terrain made the trek challenging, with the team covering just 30 kilometers in 2 weeks. However, their efforts were rewarded with the discovery of monumental structures, including a large acropolis and intriguing shapes suggesting a marketplace or cultural center. LiDAR technology also plays a crucial role in exploring other planets. Rovers equipped with LiDAR can navigate their surroundings autonomously without constant direction from human controllers. Furthermore, LiDAR helps us determine the best locations for solar panels, making it cheaper and faster to meet our energy needs. And the applications of lasers don't stop there. Scientists are exploring their use in predicting volcanic eruptions. Volcanoes are essentially pressure cookers filled with magma, molten rock rising from deep within the earth. When a volcano erupts, a chemical reaction transforms the magma into lava. Researchers are now using lasers to analyze magma, viewing it as the computer code of volcanoes, revealing clues about how a volcano might erupt. Not all eruptions produce lava, and even when they do, the lava's viscosity varies. Magma is a complex mixture of liquid, gas, and crystals swirling within the volcano. Understanding this complex chemistry is a major challenge. To simplify the process, scientists are using lasers, similar to those used in eye surgery, to bombard cooled magma samples, the rock matrix. This process breaks down the chemical components, making them easier to analyze. This advanced laser technique was recently used on samples from the 2021 eruption of a specific volcano, an eruption that lasted 85 days and covered over 4 square miles with lava. The results from this study will hopefully help scientists in the future. In 2018, the eruption of the Kilauea volcano in Hawaii unleashed a devastating flow of lava, engulfing over 1,000 homes and forcing more than 7,000 people to evacuate. To mitigate the impact of future volcanic events, scientists are tirelessly gathering data. While seismic activity and ground deformation provide crucial insights, a deeper understanding of a volcano's chemical makeup is paramount. For some, the prospect of unraveling the mysteries of these geological titans is exhilarating. For others, the rapid advancements in our understanding of volcanoes may seem unsettling. The realm of artificial intelligence is equally captivating. One compelling theory posits that AI will undergo 7 distinct stages of evolution. Let's embark on a journey through these stages to determine where AI currently stands. The first stage, known as rule-based AI, represents the foundational layer. These early iterations, while seemingly rudimentary, laid the groundwork for all subsequent advancements. They remain the unsung heroes that prevent your toast from burning or maintain a constant speed in your car via cruise control. These systems operate according to a rigid set of rules, ensuring consistency but limiting adaptability. Although rule-based systems have been around since the 1950s, they have become far more sophisticated. Consider the chatbots that greet you on various websites. These systems represent a more advanced form of AI, designed to be context-aware. While still reliant on human input, they can learn new skills, adapting their responses to specific situations. Whether providing digital assistance in customer service or offering purchasing advice, these systems are constantly evolving. The next step involves specialized AI systems that possess expertise in a particular domain. These systems can surpass human capabilities in certain areas, largely due to their ability to process vast amounts of information with incredible speed. Consider the ancient game of Go, which is similar to chess but has far more possible moves. Some estimate more moves than there are atoms in the universe. AlphaGo, a computer system, was designed to master this complex game. Initially, it learned the basic rules and aimed to win, guided by human experts. In 2016, AlphaGo faced its ultimate challenge: Lee Sedol, a renowned Go champion. Surprisingly, AlphaGo emerged victorious with a score of 4-1. Subsequently, AlphaGo Zero was developed. This iteration was a self-learner. Scientists essentially gave it a puzzle without providing the solution. Without any human assistance, it relied solely on its own processing power. AlphaGo Zero became an avid observer of Go games, analyzing thousands of matches and developing its own unique strategies. When AlphaGo Zero was pitted against AlphaGo, the results were astounding. AlphaGo Zero won with a score of 100-0. This demonstrates the remarkable capabilities of machines when they attempt to emulate human thought on a massive scale. However, these AI systems have limitations. They are akin to one-trick ponies. If AlphaGo Zero were to attempt to learn a new skill, it would forget everything it had learned about Go. Stage 4 encompasses AI systems that appear to think independently, or at least are adept at mimicking human cognitive processes. These systems do more than simply follow rules or memorize information. They can analyze literature, grasping the plot and inferring the motivations of the characters. These systems can also analyze business data and predict financial trends, potentially offering investment advice. Further along the evolutionary path lies artificial general intelligence, AGI. Experts believe that some existing systems are beginning to approach this stage. In theory, AGI systems should be capable of thinking like humans. If presented with a novel task, they should be able to devise a solution. Essentially, AGI aims to replicate human capabilities. It is important to remember that the field of AI is still in its infancy. Let's consider the very definition of artificial general intelligence. Even experts can't agree, and each has their own interpretation of what AGI truly represents. For instance, computer scientists might argue that human intelligence is rooted in setting goals and achieving them. Should AI be capable of this? If AI software could learn to do that, it would mimic the human experience. Meanwhile, some psychology experts believe that being human boils down to adapting to new situations and surviving. Viewed through this lens, AI software still has a considerable distance to travel. As we delve into the next stage of AI development, we begin to glimpse the future. These theoretical software systems are often referred to as ASI, which stands for Artificial Superintelligence. Imagine computers so advanced they surpass human intellect in both speed and depth of thought. We can only speculate on the incredible feats such technology could achieve. It might hold the key to solving some of the world's most pressing issues, from medical breakthroughs to financial stability. This type of AI could even unlock entirely new scientific discoveries, revolutionizing our economies and creating innovative forms of community leadership. The timeline for the arrival of such technology remains uncertain. Experts grapple with this very question, but most concur that we are unlikely to witness its emergence within the next decade. In the meantime, science fiction films continue to explore these fascinating concepts, and if AI were to reach its ultimate form, it would culminate in something known as the singularity. In this hypothetical future, computers would eclipse human intelligence, possessing the capacity for instantaneous self-improvement. Their evolution would outpace our ability to comprehend them. While this remains a distant prospect, the rapid advancements in AI make the singularity seem increasingly plausible. Some specialists even predict that AI singularity could become a reality as early as 2045. Hopefully, the developers of these advanced AIs will incorporate safety mechanisms along the way. This raises numerous questions. If AI machines attain such profound intelligence, could we effectively control them? Opinions on this matter diverge. Major corporations are eager to participate in the AI revolution, driven by a fear of being left behind. National governments also aspire to lead the charge in artificial intelligence. Consequently, despite the acknowledged risks, the momentum behind AI development is substantial, making a complete pause unlikely. One proposed solution involves incorporating an off switch into each AI system, providing a means to shut them down in the event of unforeseen circumstances. However, we cannot guarantee that a sufficiently intelligent AI would comply with such a plan. It might devise strategies to circumvent the switch altogether. Let's remain optimistic, though. Various forms of AI have already demonstrated their potential, transforming mundane tasks like real-time language translation into remarkable feats of magic. Everyday objects, such as watches and refrigerators, are becoming smarter, anticipating our needs. Teams of robots are increasingly prevalent, tackling tasks ranging from simple cleanups to complex repairs and even surgical procedures. AI is also making inroads into creative domains, generating designs for shoes, gadgets, and even gourmet recipes. Self-driving cars, once confined to the realm of science fiction, are now navigating our streets. It's time not only to marvel at these advancements, but also to actively participate in shaping their future. We, as humans, hold the pen and the brush. Let's ensure that the AI portrait we create is vibrant, beneficial, and serves the interests of all humanity. It has been just over a year since the launch of the James Webb Space Telescope, a project that spanned more than 2 decades. In this relatively short period, this state-of-the-art and most powerful instrument in history has already yielded a wealth of discoveries. By observing the universe at infrared wavelengths, the James Webb Telescope allows us to perceive phenomena previously hidden from view. Its primary mission is to investigate the formation of galaxies and stars in the early universe. Consider, for instance, the stellar nursery closest to us, a region of space where new stars are born. NASA has released an image captured by the James Webb Telescope, showcasing a small star-forming region. Upon closer inspection, you'll notice jets of gas erupting from infant stars. Surrounding them, clouds of cosmic dust in various colors collide and interact. The scene is truly mesmerizing. The red dust is composed of molecular hydrogen. You might also observe that some stars appear to cast shadows, hinting at the formation of future planets. At first glance, the image may seem chaotic. Imagine, billions of miles away, beyond the reach of our naked eyes, lies a realm of cosmic wonder. Astronomers peering through the most advanced telescopes ever conceived unveil sights that challenge our understanding of the universe. Among these marvels is a stellar nursery, a birthplace for stars, which, while relatively small and quiet compared to others, teems with nascent suns, many mirroring our own in size, or even smaller. This breathtaking vista was captured by the James Webb Space Telescope, specifically its near-infrared camera, or NIRCam. This primary camera acts as the observatory's all-seeing eye, capturing images of the cosmos in 2 distinct infrared ranges, revealing secrets hidden from conventional telescopes. But the Webb telescope's discoveries don't end there. Consider, if you will, the detection of smoke molecules in a distant galaxy, a monumental achievement marking the first time such complex molecules have been observed so far from Earth. This galaxy, a celestial beacon, resides a staggering 12.3 billion light-years away. It likely coalesced a mere 1.2 billion years after the Big Bang, a cosmic dawn in the universe's history. Despite the immense gulf separating this galaxy from our planet, scientists have successfully identified chemical compounds akin to those found in soot or smoke. This is an extraordinary feat, pushing back the record for detecting such complex molecules by approximately a billion years. It underscores the unparalleled power of this space-based observatory. The discovery was made even more impressive by the fact that the spectrometer, crucial for these measurements, experienced a sudden and unexpected degradation, yet still delivered groundbreaking results. The James Webb Space Telescope has also revolutionized our knowledge of exoplanets, planets that orbit stars other than our own sun. Early in 2023, the observatory pinpointed its first exoplanet, designated LHS 475b. Situated 41 light-years from Earth, it's remarkably similar in size to our own world. According to NASA, the James Webb Telescope is currently the only operational telescope capable of analyzing the atmospheres of Earth-sized exoplanets. The research team believes that these findings highlight the telescope's exceptional precision. Their hope is that it will lead to the discovery of numerous other rocky exoplanets, potential candidates for future colonization. The universe, far from being an empty void, is a dynamic arena of cosmic events, and the Webb telescope possesses the tools to witness them all. Consider the image of WR24, a star teetering on the brink of its explosive demise. The image captures the star poised to erupt in a supernova. This cataclysmic event occurs when a star exhausts its nuclear fuel and explodes at the end of its life cycle, unleashing a vast cloud of space dust and superheated gas. The star observed by the Webb telescope was in the Wolf-Rayet stage, a phase where it sheds its outer layers before its ultimate supernova. Another remarkable find is a hybrid object, a star-planet chimera shrouded in peculiar clouds. This strange world, known as VHS 1256b, is a brown dwarf. These celestial bodies are larger than planets, but fall short of being classified as true stars. They emit a faint light and possess considerable heat, but their mass is insufficient to trigger the hydrogen-to-helium fusion that powers stars. These objects aren't actually brown. They exhibit a spectrum of colors, mostly invisible to the human eye. The light they emit appears to us as dark orange or magenta. The brown dwarf discovered by the Webb telescope dwarfs Jupiter, being almost 20 times its size. It orbits two red dwarf stars and requires over 10,000 years to complete a single orbit. Astronomers initially identified this unusual exoplanet in 2016. However, they didn't classify it as a brown dwarf at the time and couldn't account for its enigmatic reddish glow. Now, thanks to the James Webb Telescope, the origin of this space object has been revealed. And what about those clouds? Unlike Earth's clouds, composed of water vapor, the clouds on this brown dwarf are made of something far more exotic: sand. It resembles ordinary sand from Earth, but it's composed of minuscule particles of silicate. In another recent discovery, scientists have identified several enormous galaxies that they believe formed shortly after the Big Bang. These galaxies shouldn't exist, and their presence was entirely unexpected. Yet, the James Webb Space Telescope has detected them. These galaxies, as massive as our own Milky Way, are teeming with mature red stars. Astronomers have analyzed the light emanating from these galaxies and estimated their age to be between 500 and 700 million years after the Big Bang. This implies that they originated when the universe was in its infancy, almost a newborn. However, the most perplexing aspect of these galaxies is their immense size and the age of the stars within them. The data gathered by the telescope don't align with prevailing theories about the early universe and its evolution. Let's journey far beyond our world to the unimaginable distances captured by the James Webb Space Telescope. What we are about to witness challenges previous understanding, even contradicting earlier observations made by the Hubble telescope. In one breathtaking image, James Webb unveils a distant region of space with unprecedented clarity. Behold Pandora's cluster! Before us, three colossal clusters of galaxies converge, an event of cosmic significance, forming a mega-cluster of unimaginable proportions. The sheer mass of these galactic gatherings acts as a gravitational lens, a natural magnifier bending space itself. Thanks to this phenomenon, scientists can now peer deeper into the cosmos, observing galaxies previously hidden from view. Astronomers are astounded, declaring that this latest image of Pandora's cluster is the most profound and detailed they have ever encountered. But the wonders don't stop there. James Webb has also revealed thousands of previously unseen young stars nestled within the Tarantula Nebula. This celestial formation earned its name from the distinctive dusty filaments that resemble a spider's web in earlier images. This is the largest star-forming region in our local galactic neighborhood, encompassing the galaxies closest to our own Milky Way. The Webb telescope's observations are revolutionizing our understanding of the Tarantula Nebula's composition. The telescope has detected protostars, infant stars still accumulating mass, cosmic embryos destined to shape the nebula's future. Among James Webb's many discoveries is the birth of approximately 50 distant stars. Some of these power protoplanetary disks, swirling clouds of gas and dust that could eventually coalesce into solar systems, light years removed from our own. And now, prepare to be humbled. James Webb has captured an image of a supermassive black hole, a behemoth with a mass equivalent to 9 billion suns. It's so vast, so ancient, that scientists are struggling to reconcile its existence with current cosmological models. Furthermore, astronomers have detected a distant ring of dust, rock, and gas containing a crucial chemical compound, methylation. This is a molecular building block of life, a key component in the creation of organic material as we know it. The James Webb Telescope has even allowed researchers to witness powerful sandstorms raging on a planet an astounding 235 trillion miles away. For astronomers, this was like discovering a treasure trove of countless minuscule sand particles swirling across an alien landscape. Now, cast your eyes upon this familiar image, the iconic pillars of creation. But look closely. This new perspective reveals a region far more densely populated with stars than previously imagined. Compare this image with the one captured by Hubble in 2014. The difference is staggering, a testament to the incredible progress of scientific exploration. Ever experienced the misfortune of riding a bicycle over nails? An unpleasant experience, to say the least. Now imagine navigating a bicycle across the surface of Mars. A landscape littered with rocks, scarred by canyons, punctuated by volcanoes, and covered in a thick layer of red dust. Suddenly, those nails seem almost benign. No ordinary tire designed for earthly roads could withstand such punishment. Since the 1960s, NASA has been tirelessly working to develop the perfect wheel for lunar and Martian exploration. They experimented with smooth rubber tires filled with nitrogen, large flexible wire mesh wheels, and airless compliant tires constructed from hundreds of coiled steel wires. The spring tire. Yet none proved sufficient for the unforgiving cosmic terrain. The wheels of the Mars Curiosity rover, for example, sustained significant damage after just over a year of operation. The rover's tires faced two primary challenges. First, they needed to be robust enough to support the immense weight of the vehicle. Engineers strived to create the most efficient exploration vehicle possible, a departure from previous lunar and Martian rovers. This resulted in a heavier design. And as we all know, a heavy vehicle requires exceptionally durable tires. Moreover, the Martian surface is far from forgiving. Engineers initially opted for aluminum, a lightweight and strong material, but the wheels were quickly shredded by the harsh environment. While the damage didn't prevent Curiosity from completing its mission, it did compromise its efficiency. That's where the reinvented wheel comes into play. NASA decided to replace aluminum with a shape memory alloy, a unique metal composed of nickel and titanium known as nitinol. Unlike conventional materials that deform permanently under pressure or heat, this remarkable substance reverts to its original shape under the same conditions. Nitinol isn't just a hero on Mars, it also holds immense potential here on Earth. Imagine tires that never puncture. One company is already applying this technology to bicycles. These tires are tube-shaped and compress when encountering a bump, gradually developing perfect shape memory over time. They are designed to excel on gravel, trails, and mountain paths. The metal surface is encased in a rubbery outer layer, providing both durability and grip. Imagine traveling back in time, not to the age of dinosaurs, but to ancient India thousands of years ago. Here, in the cradle of a vibrant civilization, we witness the birth of practices and inventions that still resonate today. Let's begin with yoga. Over 5,000 years ago, during the flourishing Indus-Sarasvati civilization in northern India, the earliest whispers of yoga echoed through the land. These weren't the precisely sculpted poses we know today, but rather the nascent seeds of a profound discipline. Over centuries, yoga was meticulously refined, evolving into a vast and intricate system. More than 200 sacred texts were dedicated to this path of enlightenment. Then, around the start of the modern era, a Hindu sage codified the practice in the Yoga Sutras, giving yoga a new trajectory. It became a holistic method for rejuvenating the body and extending life, with postures that are still practiced in studios worldwide. It wasn't until the 19th century that yoga finally reached the Western world, where it quickly spread, captivating minds and bodies alike. Now, shift your gaze to another intellectual pursuit: chess. This timeless game, a battleground for strategic minds, also traces its ancestry back to India. Its predecessor, known as Chaturanga, was a strategic board game that began gaining traction roughly 3,000 years before our current era. This early form of chess differed significantly from the game we know. It involved 4 players instead of 2, unfolded on a 64-square board, and each player commanded 8 pieces, from pawns and kings to bishops and knights. Instead of standard 6-sided dice, oblong dice determined movement. The players, positioned opposite each other, formed alliances, creating 2 teams based on their seating arrangement. The chess that we know today was first mentioned in ancient Indian literature in a captivating legend. It's said that the wife of a villain called Ravana had invented the game to amuse him. But the ingenuity of ancient India extended beyond the realms of mind and strategy. Consider the simple act of washing your hair. The very word shampoo originates from the Hindi word meaning to soothe or to knead. The practice itself was born in India in 1762, initially as a head massage using natural oils and herbs. British traders, captivated by this luxurious ritual, introduced it to England. Over time, this ancient head massage oil evolved into the shampoo we use today, a testament to its enduring appeal. While ancient Greeks draped themselves in animal skins, the people of India were pioneering the cultivation of cotton as early as the 5th and 4th centuries BCE. They wove cotton threads into fabrics that rapidly gained popularity throughout the Mediterranean and beyond. And let's not forget the luxurious world of wool. Cashmere, the epitome of fine wool, hails from the Kashmir region of India. Even the humble button adorning that cashmere cardigan can trace its lineage back to ancient India. Roughly 5,000 years ago, the Indus Valley civilization began crafting seashells into geometric shapes, meticulously drilling tiny holes into them. Initially, these were mere decorations, but soon they found a practical purpose: fastening clothing. When we think of radio communication, the name Marconi often dominates the narrative, deservedly so, as he received the Nobel Prize in Physics in 1909 for his groundbreaking work. Yet, there exists an unsung hero in the saga of radio waves: Sir Jagadish Chandra Bose. In 1895, Bose unveiled the secrets of radio communication, demonstrating its power by transmitting an electromagnetic wave across 75 feet at the town hall in Kolkata. The wave traversed walls, rang a bell, and even ignited gunpowder. Marconi, it is believed, drew inspiration from Bose's invention, the mercury coherer, as a foundation for his own two-way radio. Tragically, Bose did not patent his ingenious creation, and recognition for his contribution came only a century later. Now, let's turn our attention to a mystery unearthed in the sands of Egypt. In 1936, British Egyptologist Walter Bryan Emery stumbled upon a peculiar object in the desert, igniting a debate that continues to this day. Was it an intricately carved stone model of a flying saucer? Or perhaps a hyperdrive from an extraterrestrial spacecraft that visited Earth millennia ago? Emery dedicated years to excavating sites along the Nile River Valley, particularly the sprawling necropolis of Saqqara. He unearthed countless treasures from ancient Egypt, but none as perplexing as the artifact discovered in the tomb of Sabu, a high-ranking official whose identity remains shrouded in mystery. Some accounts suggest he was a king's son, and his burial at Saqqara indicates his prominence in the royal court. Sadly, no records from his era survived, leaving Sabu's role and fate an enigma. Within Sabu's tomb, scientists discovered 17 burial chambers, each brimming with traditional grave goods. Animal bones, flint tools, pottery, ivory objects, and stone bowls. And then there was the enigmatic broken artifact, now known as the Disc of Sabu. It resembles a shallow, round-bottomed bowl, but with 3 gracefully curved lobes carved around its perimeter, spaced approximately 120 degrees apart. These lobes are separated by 3 holes, and a slender tube pierces the center. The disc is crafted from metilled stone, or schist, a fragile, porous, and notoriously difficult material to carve. Let's journey back to a time before heart surgery and memory foam mattresses, a time ruled by giants. But hold on, we'll get there. Imagine a future where flat tires are a distant memory. A company is developing airless tires that promise to banish punctures forever. These aren't your grandpa's solid rubber tires, though. The plan is for these tires to be retreaded, extending their lifespan for years to come. Previous models, crafted from patented foam, aimed for a 5,000-mile lifespan, but their excessive weight proved a major drawback. This new design seeks to overcome that challenge, offering a lighter, more practical solution. But the wonders of material science don't stop there. Consider nitinol, a shape memory alloy with remarkable applications in heart surgery. Imagine tiny tubes made of this material, capable of expanding to the precise width required within the human body, all triggered by temperature. And speaking of comfort, who can imagine sleep without a memory foam mattress? We owe a debt of gratitude to NASA for this innovation. Back in 1966, the space agency sought to cushion astronauts from the intense G-forces experienced during takeoff and landing. Custom seats for every flight seemed impractical, so memory foam came to the rescue. It conformed to the astronaut's body shape and returned to its original state when not in use. By the 1980s, memory foam had made its way to Earth, finding applications in mattresses, pillows, amusement park rides, horseback saddles, and even football helmet liners. The latest generation of memory foam incorporates gel particles and viscofoam, enhancing its ability to dissipate body heat, quickly recover its shape, and provide a cloud-like softness. Then there are space blankets, another NASA invention. In the 1960s, as the space age dawned, NASA sought a thin, reflective material to shield spacecraft from solar radiation. The result was a material strong enough to insulate sensitive electronics from extreme temperature fluctuations. These blankets became essential on nearly every mission beyond Earth's orbit. They also protect astronauts from radiation and solar heat during spacewalks. Back on Earth, marathon runners rely on space blankets to regulate their body temperature after a race. The same material can even protect your phone from extreme temperatures when used as insulation in a phone case. In the early 1960s, airline pilot headsets were bulky and cumbersome, often requiring handheld microphones. NASA needed a more reliable and lightweight communication system for its missions. In 1961, the Liberty Bell 7 capsule splashed down, and astronaut Gus Grissom nearly sank without radio contact. NASA tasked a manufacturer with designing a headset that could be integrated into an astronaut's helmet. Just 11 days later, the team delivered a microphone headset with noise-canceling capabilities for communication between astronauts and Earth. This headset was further refined for the Mercury and Apollo missions. Thanks to this wireless headset, the world heard Neil Armstrong's famous words as he stepped onto the moon. Freeze-drying technology, while not invented by NASA, was significantly improved to provide astronauts with more palatable food on long Apollo missions. During the initial human spaceflights, astronauts were limited to bite-sized cubes, freeze-dried powders, and semi-liquids squeezed from aluminum tubes. Unappetizing to say the least. For the Gemini missions, NASA funded research that led to the development of special gravies that could be rehydrated with hot water in just 5 minutes. Freeze-drying involves cooking food, freezing it under low pressure, and then slowly heating it in a vacuum chamber to remove ice crystals. This process preserves 98% of the food's nutritional value while reducing its weight by 80%. NASA continued to refine the technology, and today, freeze-dried food is a staple for backpackers, disaster relief programs, and anyone needing lightweight, nutritious meals. Even the infrared thermometer, allowing us to measure temperature from a distance, owes its development in part to NASA. It measures thermal radiation emitted by the eardrum, similar to how astronomers measure the temperature of stars and planets. A lens focuses light from the object onto a detector, which converts the radiation into an electrical signal. Imagine, for a moment, a device capable of seeing heat. Not just feeling it, but visualizing it like a vibrant painting. This is the power of thermal imaging. It's a technology that reveals the invisible world of temperature, finding applications in the most unexpected places. From pinpointing overheating components in complex machinery and electrical grids, preventing potential disasters before they strike, to discreetly screening individuals in public areas, identifying those with elevated temperatures. But what about something far more commonplace, almost ubiquitous in our modern lives? The selfie. Prepare to be surprised. The very technology that allows us to capture those fleeting moments of our lives, those self-portraits we share with the world, has roots in the ambitious realm of interplanetary exploration. Let's journey back to the 1990s. At NASA's Jet Propulsion Laboratory, brilliant minds were crafting ingenious solutions for the challenges of space travel. They developed a compact, energy-efficient imaging system, a miniature marvel capable of capturing high-resolution images from the vast emptiness of space. This groundbreaking technology, born from the demands of interplanetary missions, found its way into the cameras of our cell phones and computers, empowering us all to become photographers. Now, let's rewind even further, to the dawn of the space age, the 1960s. We find a compelling precursor to the modern selfie, a moment of personal expression amidst the monumental achievement of lunar exploration. Edwin "Buzz" Aldrin, the second human to set foot on the moon, armed with a specially designed Hasselblad camera, captured a series of self-portraits against the stark alien landscape. He ingeniously used the lunar module itself as a makeshift tripod, ensuring a steady shot and immortalizing his presence on that distant world. So, should you ever find yourself in the extraordinary situation of being in space, remember Buzz Aldrin's ingenuity. Even among the stars, a selfie is within reach. The material is incredibly fragile. It practically crumbles to the touch. The real puzzle is how ancient artisans, armed with rudimentary stone and copper tools from around 3000 BCE, managed to fashion this disc. It remains an enigma. And then there's the question of why Sabu was buried with it. Understanding its true purpose might unlock the answer. Initially, upon its discovery, archaeologists dismissed it as a mere vase, perhaps an incense burner, or simply a decorative object used in ceremonies. However, a more analytical, engineering-focused examination suggested a different story. Could it be a component of a larger, more complex machine? One amateur historian, driven by curiosity, created an exact replica of the artifact using a 3D printer. The results were astonishing. The disc of Sabu appeared to be an ancient impeller, a critical element in a centrifugal pump. Imagine this disc, placed within a housing and spun at high speeds using that small central shaft. It would have been capable of displacing water with considerable force. Even without a housing, tests revealed that the disc generated a powerful vortex. It became undeniably clear that the curved lobes and the subtly concave shape of the disc weren't accidental. They were meticulously engineered to move water with remarkable efficiency, functioning as a powerful pumping mechanism. Ancient Egypt's very existence hinged on effective irrigation. Later dynasties would refine basin irrigation techniques, mastering the ebb and flow of the Nile to maximize agricultural yields. Could it be that the engineers of the first dynasty were experimenting with advanced irrigation methods thousands of years before previously believed? However, not everyone is convinced. Some argue that schist simply isn't durable enough for a pumping mechanism. They propose that the artisans of Egypt's first dynasty were attempting to replicate an even older artifact using whatever tools and materials were available to them. Perhaps it was a stone copy of something originally crafted from metal, potentially belonging to a civilization far older and technologically superior to ancient Egypt itself. One Swiss author takes this idea to an even more outlandish extreme. He suggests that the disk is a replica of a component from an extraterrestrial spaceship's hyperdrive, or a stone model of a flying saucer. A French researcher posits that the disk of Sabu was a piece of a secret, large-scale factory system designed for the manufacture of sodium carbonate inside the pyramids. Others propose a more mundane purpose, a primitive tool for weaving ropes. The lobes, they suggest, held strands of silk or fiber that were twisted into twine as the disk was spun. Or perhaps it was simply a gigantic lamp. Another enduring historical puzzle is a map dating back to 1513, widely regarded as the oldest surviving detailed map depicting the Americas. The map's creator was a Turkish captain named Piri Reis. Although he never personally crossed the ocean, he compiled this map from no fewer than 20 regional maps. He drew upon an Arab map of India, 4 Portuguese maps illustrating India and China, and a map of America created by Christopher Columbus, based on Columbus's own observations. This last map has been lost to time. Rice's map offers us a tantalizing glimpse into what Columbus must have recorded during his third voyage to the New World. One historian, after meticulously studying the map, even suggested that it depicted Antarctica in prehistoric times. The coastline strangely resembled Antarctica's true shape, as it would have appeared when free of ice. However, this theory was later debunked. Another intriguing discovery that once shook the scientific community was the Klerksdorp spheres. These objects, discovered in deposits of mineral pyrophyllite in South Africa, resemble tiny ancient cricket balls with lines encircling their middles. Back in the 1980s, a theory emerged suggesting that an incredibly advanced pre-deluge civilization, lost to history, had created these spheres. One journalist even shared accounts of the spheres rotating on their own within a display case. A television show further fueled the speculation, inviting a psychic who proclaimed that the spheres were components of an ancient spaceship. However, geologists have since offered a more grounded explanation. These spheres are relatively ordinary spherical objects composed of different minerals than the surrounding rock. The seam-like lines are simply imprints left by the host rock's layers as they built up over time. The Klerksdorp spheres come in various shapes, ranging from flattened spheres to distinct disks. As for the episode in which one of these spheres appeared to spin spontaneously, the curator of the Klerksdorp Museum has set the record straight. He explained that when he placed one of the spheres on a glass shelf during the journalist's visit, the sphere rotated slightly simply because it was round. Furthermore, nearby gold mining activities frequently cause earth tremors in the area where the museum is located. Deep within a remote region of China lie some bizarre pipe-like formations known as the Baigong Pipes. A local explorer stumbled upon these structures back in 1996, protruding from Mount Baigong and along the shores of the nearby Tosin Lake. Some initially theorized that they were the work of... Imagine stumbling upon relics that defy explanation, whispering tales of forgotten civilizations and technologies beyond our current understanding. Let's journey into the shadowy corners of archaeological mysteries, where the line between fact and speculation blurs. Our first stop, a remote region where peculiar pipes jut from the earth, remnants that some whisper are relics of ancient extraterrestrial visitors. When scientists analyzed these enigmatic pipes, they found a composition primarily of common minerals. However, a baffling 8% remained unidentified, defying categorization. Further investigation revealed a startling truth. These structures predated humankind. Later, Chinese geologists ventured to the site, proposing a terrestrial origin. Their theory suggests the pipes are fossilized tree roots, remnants of a lush, ancient ecosystem. Yet the enigma persists, a mystery without a definitive solution. Now, let's travel to Romania, where construction workers unearthed an object that would become known as the aluminum wedge of Aiud. This artifact was discovered alongside the bones of mastodons, those ancient relatives of modern elephants that roamed the earth over 11,000 years ago. The implication? The wedge might be of similar age. What makes this find truly extraordinary is its composition. Aluminum. This metal wasn't discovered until the 19th century, and its production requires intense heat. The wedge bears a thick coating of oxide, suggesting it has rested in the earth for centuries. Some speculate that the wedge is a fragment of an alien spacecraft that crashed on Earth millennia ago. While some scientists dismiss the find as a hoax, others suggest it could be a man-made object of unknown purpose. Our journey continues to Egypt in 1850. French scientist Auguste Mariette sought ancient manuscripts, but instead he uncovered the head of the Great Sphinx protruding from the desert sands. Clearing away the accumulated sand, Mariette realized the Sphinx guarded the entrance to a subterranean complex. Months later, he finally breached the Serapeum of Saqqara. Inside, he discovered colossal granite sarcophagi, alongside the remains of 64 bulls. The engineering prowess of the ancient Egyptians, their ability to transport these massive boxes, continues to astound scientists today. The Serapeum, constructed around 3000 BCE, served as an underground tomb dedicated to the sacred Apis bulls of ancient Egypt. A long corridor, nearly 500 feet in length, led to massive stone chambers on either side. Some of these sarcophagi weighed as much as 50 modern cars. Each was crafted with incredible precision, boasting perfect 90-degree angles. Hieroglyphs and carvings adorn the sarcophagi, narrating the lives and significance of the Apis bulls. Today, 24 sarcophagi remain in ancient Egypt. Apis bulls held a revered status in ancient Egyptian society, believed to be connected to the deity Ptah. They were thought to embody Ptah's spirit and wisdom, guiding the pharaoh and protecting the Egyptian people. Priests sought out specific markings on young bulls to identify the chosen Apis. These markings could include a white triangle on the forehead, symbolizing divine light, a shape on the back resembling a vulture's wing, and a scarab shape beneath the tongue, representing rebirth. If a bull possessed these traits, it was believed to be chosen by Ptah and treated as royalty. These chosen bulls lived in a special temple in Memphis, the center of Ptah worship. They received the finest care and offerings from visitors seeking their blessings. Upon an Apis bull's death, it was honored with elaborate mummification rituals. When Mariette entered the Serapeum, he observed traces of rollers on the gallery floor and discovered 2 wooden winches, each with 8 levers. Later, other explorers found evidence of double rails. The burial chambers lay below the hallway floor. To maneuver the sarcophagi into place, workers filled the chambers with sand, allowing the massive boxes to be rolled in. Then, they gradually removed the sand, gently lowering the sarcophagi into precisely cut spaces in the bedrock. A carved stone inscription revealed that it took 28 days to move a single sarcophagus and its lid into position during the reign of Thutmose II. The remarkable precision of the sarcophagi, with their 90-degree angles, can be attributed to the ancient Egyptians' mastery of geometry. Ancient papyri reveal their knowledge of the approximate value of pi and their ability to calculate the volume of a truncated pyramid. Their mastery of complex mathematics suggests they were capable of carving perfectly flat surfaces centuries later. While this explanation seems plausible, some argue that certain aspects remain perplexing. The sheer size of the sarcophagi far exceeds the size of the bulls they were intended for. Furthermore, pharaohs were buried in relatively small coffins, while the sarcophagi were crafted from granite with incredible precision, despite the availability of limestone, a far easier material to work with. The transportation method, while seemingly straightforward, would have required an immense workforce. If one person could pull approximately 440 pounds, then at least 250 people would be needed to move a single sarcophagus. And finally, the tunnels within the Serapeum are remarkably narrow. Imagine standing in a narrow corridor, barely wider than the massive stone boxes that line its walls. We're not talking about a few boxes. There are 24 of these colossal granite containers, each perfectly centered in its niche. Now, consider this. How could hundreds of people have possibly squeezed into such a confined space to maneuver these multi-ton behemoths? Even if they could, how would they have managed to turn these boxes in the cramped corridors, guiding them into their designated spots with such precision? It seems almost impossible, and the mystery deepens. The chambers are filled with dust, yet there's no trace of soot from lamps. This suggests that the ancient workers toiled in near total darkness. What were these boxes truly used for? Perhaps their purpose was far different than we imagine. Let's journey back even further, to a time before the pharaohs ruled Egypt. The local people possessed a knowledge of fermentation, a process where microscopic organisms called yeast consume ingredients like starch, transforming them into gas and ethanol. Picture this: someone in ancient Egypt placing barley, bread, or even meat inside one of these giant stone boxes, then sealing it tightly with a massive lid. These boxes, hewn from granite, were crafted with such precision that they were practically airtight. As the yeast within began its work, it generated increasing amounts of CO2 gas, building up immense pressure inside. The granite boxes, incredibly robust, could withstand pressures exceeding that of a car tire. Here's where it gets even more intriguing. When granite is subjected to intense pressure, its crystals emit a tiny electrical charge. This phenomenon occurs because granite contains quartz, a material known to react to pressure in this way. The fermentation process also required meat or animal parts, perhaps to nourish the yeast and bolster its growth. Meat contains oleic acid, a substance crucial for yeast's survival and resilience against the harmful effects of ethanol. As the pressure within the box continued to escalate, the combination of gases and electricity transformed these containers into more than just ancient refrigerators. They became powerful energy systems. Over time, the pressure could become so extreme that it forced the lid open, releasing the accumulated gas with a resounding pop. But here's another twist. When the Serapeum was rediscovered in 1850, archaeologists found ancient drawings depicting piles of stones stacked atop some of the box lids. This suggests that someone, long ago, attempted to augment the weight of the lids, making it even more challenging for the gas pressure to force them open. This additional weight would have also intensified the pressure on the quartz crystals within the granite, causing them to generate even more electricity. If someone were to open one of these stone boxes millennia later, they would likely find only the bones of bulls, remnants of the original contents. And that's precisely what Auguste Mariette discovered in the 1850s. Soon after the initial excavations, the Serapeum was open to visitors. The Prince of Wales even hosted a luncheon with his guests inside one of the sarcophagi. Though sands and earthquakes rendered the site inaccessible for a period, it is now open once again, beckoning you to unravel its mysteries. With the advent of new technologies, we stand on the precipice of solving numerous other historical enigmas. Consider the team of scientists at Chicago's Field Museum of Natural History. They recently employed a specialized CT scanner to delve into the secrets of ancient Egyptian mummies without disturbing their wrappings. They carefully transported 26 mummies on custom carts to the parking lot, where the scanner awaited. The scanner captured thousands of detailed X-ray images of each mummy and their respective coffins. These images were then compiled to create three-dimensional renderings, revealing the skeletons and artifacts concealed within. The scientists hope that these images will illuminate ancient Egyptian burial practices dating back over 3,000 years. While the scanning process itself took only 4 days, the analysis of the data may require up to 3 years. Nevertheless, scientists have already gleaned personal details about the mummies. One of the museum's most celebrated mummified individuals, Lady Shenetta, was a woman who lived in ancient Egypt approximately 3,000 years ago. It appears she died in her late 30s or early 40s. To ensure her body appeared complete for the afterlife, embalmers stuffed her neck to prevent it from collapsing. They also placed artificial eyes in her sockets, granting her sight in the next world. She was swathed in exquisite linen and placed within a beautifully adorned coffin. The scans revealed that the coffin was meticulously crafted with a slit in the back, which the embalmers used to position the body. Artistic details, such as markings for her knees, adorned the surface. Her burial was akin to the opulence of a high-end luxury car. Imagine a world free from the tangles of wires, a world where electricity flows invisibly through the air. It might sound like science fiction, but scientists are actively working to make this a reality. And no, we're not talking about bolts of lightning arcing across the sky. The method they're developing relies on something far safer: magnetic fields. Picture a special coil of wire engineered to generate a magnetic field when energized. Now, bring another coil within range. This second coil acts like a receiver, absorbing the energy from the magnetic field and converting it into usable electricity. Suddenly, a light bulb flickers to life, drawing power from thin air, without a single plug in sight. Reassuringly, the World Health Organization has declared these magnetic fields perfectly safe for human exposure. In fact, you may already be familiar with a rudimentary form of wireless power. Consider your electric toothbrush nestled on its charging base, or your smartphone resting on a charging mat. Electrical energy leaps across the gap between them. Inside the charger resides a specialized coil that, when energized, creates an invisible, swirling field of energy. The toothbrush or phone contains a corresponding coil that captures this energy and transforms it back into electricity, replenishing the battery. This process, known as electromagnetic induction, is already a part of our lives. However, this method has limitations. Its range is short, rendering it impractical for powering an entire house. But the race is on, and several companies are striving to refine and perfect this technology. One such company has pioneered a method called air cord, designed to transmit power through the very air around us. This technology is already integrated into real-world applications. Think of those small video screens you sometimes see beside products in supermarkets, displaying dynamic images. These screens operate entirely without batteries or cumbersome power cords. Another ingenious application is a smart lock, also developed by this company. Traditional electronic smart locks demand powerful batteries, but this innovative lock remains perpetually powered, drawing energy from a wide-range transmitter embedded in the ceiling. This transmitter functions like an invisible power outlet, operating on principles similar to a TV remote, where an infrared beam controls the device from a distance. In this scenario, the transmitter converts electricity into an infrared beam, directing it to all devices requiring power. The transmitter intelligently analyzes each device, determining its specific power needs, much like a Wi-Fi router manages internet traffic for various devices. When no devices require charging, the transmitter enters a low-power sleep mode, periodically awakening to check for any devices in need of energy. Nikola Tesla, the visionary inventor and electrical engineer whose groundbreaking work laid the foundation for modern electricity, would undoubtedly be thrilled to witness these advancements. He envisioned a world where electricity and communication signals could be transmitted wirelessly across the globe, utilizing the Earth's ionosphere. To demonstrate his concept, he constructed the ambitious Wardenclyffe Tower in New York. Tesla's audacious plan involved harnessing the Earth itself as a colossal electrical circuit. In 1899, he ventured to Colorado Springs, a region renowned for its intense thunderstorms. There, he established a laboratory to rigorously test his wireless electricity theories. The area's high altitude and frequent lightning storms provided the ideal conditions for his experiments. Subsequently, he returned to New York and, with the backing of a wealthy investor, embarked on the construction of the Wardenclyffe Tower. Tesla strategically placed iron rods and copper plates beneath the tower, intending to facilitate the transmission of power through the Earth. A massive metal dome was to crown the tower. By 1902, the tower and laboratory were nearing completion, but Tesla encountered crippling funding shortages. The Wardenclyffe Tower never achieved its intended purpose. Tragically, in 1917, it was dismantled and sold for scrap. In retrospect, Tesla's initial approach was limited by range. The farther the electricity traveled, the weaker it became. Scientists recognized the need for a method to transmit energy over vast distances. And in the mid-20th century, they identified two promising solutions: microwaves and lasers. In 1964, engineer William C. Brown achieved a remarkable feat, piloting a miniature helicopter for 10 continuous hours, powered solely by microwaves. Then, in 1975, Brown collaborated with NASA scientist Richard Dickinson to transmit 30,000 watts of power across a distance of 1 mile, utilizing a research station known as Venus. However, a significant challenge remained. Approximately half of the transmitted power was lost en route. Over time, relentless technological advancements have continued to refine these methods. Computers, lasers, solar panels, and transistors have become increasingly sophisticated, opening up new possibilities for wireless electricity. This technology holds the potential to facilitate a transition to cleaner energy sources, reducing our reliance on fossil fuels like coal and gas. Consider the innovative approach of New Zealand-based company Emrod. They employ power beaming technology, converting electricity from the power grid into microwaves. These microwaves are then transmitted through the air from a sending antenna to a receiving antenna, where they are reconverted into usable electricity. But there's a hurdle to clear. Different types of electromagnetic waves behave in unique ways. Microwaves, for instance, excel at long-distance travel with minimal energy loss, making them perfect for delivering power to isolated islands or sprawling factory complexes. However, attempting to beam microwaves from space necessitates a receiver the size of a major city. Lasers offer a solution by creating a smaller, more concentrated energy beam, allowing for a significantly smaller receiver. The catch? Lasers are vulnerable to interference from clouds, fog, and even dust particles. At present, power beaming isn't poised to replace traditional power lines across vast landscapes, but it holds immense potential for smaller-scale applications such as wirelessly charging airborne taxis and delivery drones, energizing robots in urban and industrial environments, and serving as a reliable substitute for backup generators during emergency situations. Nations worldwide are investing heavily in power beaming technology. Europe is channeling its efforts into clean energy solutions. The Japanese Aerospace Exploration Agency, JAXA, envisions a colossal solar power station in Earth's orbit, diligently collecting sunlight and transmitting electricity back to the planet by the 2030s. This orbital power plant could potentially deliver a staggering 1 gigawatt of energy, equivalent to the output of a large-scale nuclear power plant in a single year. Although the space power station remains a project in development, the underlying technology is rapidly advancing and becoming increasingly cost-effective. Imagine a future where tangled wires and unsightly power lines are relics of the past, and perhaps even a world where electricity is freely accessible to all. Japanese scientists are also pioneering another revolutionary technology, a specialized machine capable of transforming sunlight and water into clean-burning hydrogen fuel. This sustainable energy source could one day power everything from cars and homes to entire metropolitan areas. The current prototype reactor is the size of a modest house. It operates using photocatalytic sheets, which function like miniature solar panels, absorbing sunlight and initiating a chemical reaction that splits water molecules, H2O, into oxygen, O2, and hydrogen, H2. The hydrogen is then collected and utilized as fuel. Currently, the process lacks the efficiency required for large-scale hydrogen production. Most conventional hydrogen production methods still rely on fossil fuels. However, the scientists behind this innovative reactor have devised a more efficient approach. Rather than breaking water molecules apart in a single energy-intensive step, their machine performs the process in 2 stages. First, it separates oxygen, and then it collects hydrogen, streamlining the process and enhancing its effectiveness. The team employed a specialized photocatalyst that responds to ultraviolet UV light. Under natural sunlight, they observed a solar energy conversion efficiency that was 1.5 times higher than in laboratory settings. In regions with even more intense sunlight, the efficiency could be even greater. However, at its current stage of development, the reactor achieves only about 1% efficiency, far below the threshold for commercial viability. Scientists estimate that achieving practical application of this technology requires boosting efficiency to at least 5%. This will necessitate the development of more effective photocatalysts and the construction of larger reactors. Furthermore, safe and reliable methods for handling a potentially hazardous byproduct, a highly flammable gas produced during the process, must be established. But if they succeed in significantly boosting efficiency, numerous scientists and companies will undoubtedly invest in mass producing this technology, paving the way for widespread access to clean, renewable hydrogen energy. Imagine you are presented with a choice: two pills, one red, one blue. Choose the blue pill, and life continues unchanged as you perceive it. Opt for the red pill, and you awaken to the world as it truly is, a meticulously crafted simulation. This, of course, is the premise of The Matrix. But the notion that we might be living within a virtual reality is not merely science fiction. It's a legitimate scientific hypothesis. And perhaps, just perhaps, we can break free. Scientists refer to it as the simulation hypothesis. Everything you see, feel, and experience, from the rush of adrenaline when you meet your soulmate to the allure of that dream car, could be nothing more than intricate lines of code within a hyper-realistic computer system. Let's entertain the possibility that this theory holds true. How might such a simulation function? Essentially, there are two primary types of virtual worlds in which we could find ourselves trapped. First, there are owned simulations. In this scenario, a clear central authority, akin to a game master, orchestrates every aspect of our experience. Think of it as a sophisticated video game. In this case, you are essentially an avatar from The Sims, and an external entity is manipulating your world. This higher being dictates your profession, determines when you need to use the restroom, and might even ignite a fire in your kitchen just for amusement. Or perhaps for sociological research. This super-intelligent entity might have created the simulation to observe the unfolding of human history, testing various events with different initial conditions to analyze our responses to diverse challenges. For example, they might introduce dinosaurs onto the planet to assess how we would cope with such a drastic change. Consider the impact of a Tyrannosaurus rex, suddenly appearing in the 21st century. Or perhaps a pack of velociraptors, Velociraptor mongoliensis, hunting in the streets of modern cities. These are all variables that could be tested within the simulation. Imagine, for a moment, that the cataclysmic meteor strike that ended the reign of the dinosaurs wasn't the end of everything. What if that event, and all of our existence, is part of a larger experiment? Perhaps some unseen entity is testing the very limits of human problem-solving. That could explain why we don't live in a flawless, utopian virtual reality. But who are these architects? What kind of beings could be orchestrating our reality? Perhaps they are transcendental entities, beings so far beyond our comprehension that we can scarcely grasp their existence. Or maybe they're extraterrestrial. Consider this. If one civilization in the vast expanse of the galaxy mastered the art of creating high-fidelity simulations, they could potentially generate billions of virtual civilizations, each teeming with trillions of simulated beings. All it would take is computers of unimaginable power. This idea might even shed light on the Fermi paradox, the perplexing question of why we've never encountered other intelligent life, despite the high probability of numerous civilizations existing in the Milky Way. If we are, in fact, living within a simulation governed by cosmic entities, we might be unable to perceive or interact with them unless they consciously allow it. Alternatively, our grand architect could be a super-advanced artificial intelligence, a control-freak version of something like ChatGPT. This brings us to another possibility: hostless simulations. Imagine a virtual world running without a central authority, like an AI-generated story unfolding on its own. In this scenario, the creator is gone, but the simulated world continues to evolve. Think back to Star Wars Galaxies, the massively multiplayer online role-playing game released in 2003. It offered players a vast, open world to explore, free from rigid storylines. Though the official servers were shut down in 2011, dedicated fans continued to play on private servers. However, without ongoing updates and oversight, the game became prone to glitches, anomalies that stretched beyond the original design. Yet, the game persisted. Now, imagine that same scenario applied to our own reality. The hostless simulation theory suggests that our universe is a chaotic and imperfect construct, and that humans themselves are a kind of glitch. Instead of being deliberately created, our consciousness and existence might have arisen from a technical malfunction. We could be nothing more than bugs in the code, anomalies trapped within a simulation running on autopilot, with no owner at the helm. This leads to a potentially catastrophic outcome. If the simulation becomes overwhelmed with glitches, it could ultimately collapse. The more we learn, the more precarious our situation might become. Our cultural and intellectual evolution could trigger a game-over scenario or a frozen screen because whoever or whatever originally created the simulation might not want us to unravel its secrets. They might choose to reset the system or eliminate the source of the glitch, which could very well be humanity itself. Consider the example of Final Fantasy XIV. The game's initial release in 2010 was plagued with bugs and technical problems. The issues were so severe that the game was shut down, and the developers embarked on a complete rebuild. This led to the release of Final Fantasy XIV, a realm reborn, a vastly improved version. A similar rebirth might await us. Imagine that, a century from now, we develop an AI capable of simulating entire human civilizations. This AI could draw upon vast troves of data, internet archives, DNA samples, photographs, videos, to recreate everyone who has ever lived in a virtual world, granting them a kind of digital reincarnation. However, our knowledge of the past is incomplete, especially as we reach further back in time. This means that the simulation would inevitably contain inaccuracies. Whether our universe is governed by a higher architect or the unpredictable forces of a super-advanced AI, some experts believe that the possibility of living in a simulation is very real. So, how might we attempt to hack the system? First, we could begin by exploring the illusion itself. Look for inconsistencies, glitches, or patterns that might reveal the underlying structure. Pay attention to things like déjà vu, which could be a sign of the simulation repeating itself. Second, we could try to overload the system with massive amounts of data. This could potentially cause errors and push the simulation to its limits. Third, we could attempt to crash the entire system by making everyone aware of its simulated nature. At some point, the simulation might reveal its true form, or simply shut down altogether. The idea that we might be living in a virtual world is certainly compelling, but how likely is it? Some scientists estimate that there's a 50-50 chance that Earth is a simulation. However, the odds might be even higher, given the infinite number of potential simulated worlds, each containing simulated people who have created their own simulations. Imagine, for a moment, that our reality is not what it seems. What if we are living in one of countless simulated worlds? Consider the implications. Mathematically speaking, the chances of our existence occurring in the one, true, physical world are staggeringly small, almost vanishingly zero. While definitive proof remains elusive, some experts propose that evidence of this simulated reality surrounds us. It might be as subtle as the sensation of déjà vu, that unsettling feeling when you believe you've experienced something before, even as it unfolds for the very first time. This could represent glitches, momentary cracks in the virtual reality matrix. Another intriguing piece of potential evidence lies in what's known as the Mandela effect. This phenomenon occurs when a substantial group of people collectively misremember an event, sharing a false memory. Take, for instance, the iconic Star Wars scene. Many vividly recall Darth Vader declaring, "Luke, I am your father." However, the actual line delivered was, "No, I am your father." To some, such discrepancies serve as compelling evidence that our reality is, in fact, a simulation. And while the metaphorical red pill remains undiscovered, we are beginning to understand that cracking the code may not be entirely beyond our reach. Perhaps it's time to alert Keanu Reeves, just in case. Let's shift gears to the world of light. Traditional LEDs, light-emitting diodes, have illuminated our lives for years, producing colors like red and green. However, the creation of blue LEDs proved to be a formidable challenge, owing to the complexity inherent in the manufacturing process. It wasn't until 2014 that three Japanese researchers were awarded the Nobel Prize in Physics for their groundbreaking work in bringing blue LEDs into existence. Their innovation centered on a novel semiconductor material known as gallium nitride, which facilitated the efficient emission of blue light. This monumental breakthrough not only revolutionized the lighting industry, but also paved the way for sustainable energy solutions. By combining red, green, and blue LEDs, we can produce white light. Alternatively, blue light can be used to excite a chemical layer within a bulb, resulting in the emission of white light. LED lighting offers superior energy efficiency compared to other lighting technologies, representing a transformative change for the 1.5 billion people worldwide who lack access to electricity grids. If all lighting were to transition to LEDs, global electricity consumption for lighting could plummet from 20% to a mere 4%. Furthermore, certain LED systems are designed to dynamically adjust the light color throughout the day, harmonizing with the body's natural circadian rhythms and providing a more comfortable and natural lighting experience. Now, let's journey into the realm of atomic structures. Scientists had long theorized about the existence of materials composed of single atomic layers, but isolating such a layer remained an elusive goal. For years, researchers pursued this objective using sophisticated and costly methods. The breakthrough arrived unexpectedly when a group of scientists employed a remarkably simple and inexpensive tool, ordinary sticky tape, to isolate a single sheet of graphene. In 2004, a team of scientists formally announced the discovery of graphene, an incredibly thin layer of carbon, just a single atom thick. This discovery sent ripples of astonishment through the scientific community, as it had been widely believed that materials like graphene would be inherently unstable and unable to exist in isolation. Graphene rapidly became a focal point of intense scientific interest, with new findings regarding its unique properties continually adding to the excitement. In recognition of their pioneering work, the scientists were honored with the Nobel Prize in Physics in 2010. The prevailing belief that strictly two-dimensional arrangements of atoms would be unstable was deeply entrenched, but recent research has challenged this assumption. Graphite, the familiar material found in pencils, is composed of layers of carbon atoms arranged in a hexagonal pattern. These layers are what we now recognize as graphene. Intriguingly, the earlier discovery of structures like buckyballs and nanotubes had hinted that carbon might, in fact, be capable of forming stable two-dimensional sheets. One of the most captivating characteristics of graphene is its exceptional electrical conductivity, enabling it to carry substantial electrical currents at room temperature. Its unique properties have unlocked a vast array of possibilities in the fields of electronics and materials science. Researchers are actively exploring graphene's potential applications in diverse areas such as solar energy and battery technology. Finally, let's consider the evolution of touch screens. The concept of touch-sensitive screens on devices has been present in our collective imagination for quite some time, even appearing in science fiction movies and books. However, the actual development of the technology needed to accurately sense and respond to finger touches on screens proved to be a lengthy and challenging endeavor. While many associate Steve Jobs with the invention of the touch interface, this is not entirely accurate. He played a pivotal role in popularizing the technology and bringing it to mainstream attention. Apple engineers invested significant effort in refining and enhancing the technology, introducing features like scrolling without the need for physical buttons. The first touchscreen device is believed to be the creation of American professor Samuel Hurst in the early 1970s. He was seeking a way to automate the process of reading information from recorder tapes, which ultimately led to the invention of the world's first touchscreen. Over the years, touchscreen technology continued to advance, paving the way for the development of the sophisticated touchscreen